We're here today getting ready to work on a pair of older 283 heads. These heads came in from a customer. They're doing a restoration on some sort of vehicle. I don't know exactly what it is, but they just want them put back as close to new as what we can possibly do. It's looking a little spooky today. Seems we've been invaded by the birds. I don't know where these have all come from, but the birds are just thick out here in the trees and in the edge of the cornfield out here today. Kind of spooky. I don't like birds. Not that many birds.
Real quick shout out to our fan Ethan and his future bride Sarah. We appreciate the wedding invite and we're sorry that we won't be making it out, but we're sending our best wishes and hope you enjoy your special day and future to come. Let's wish them a happy wedding day in the comments.
I'll show you what we're working with here today. This is a pair of Chevy 283 heads, casting number 3884520, B156. So that was February the 15th of 1966. The mate over here was cast 2 days later, B17 of 66. These are the heads that have the rectangle with a single point on the top here. These are what I always referred to, and maybe I'm right or wrong, but referred to these as being the power pack heads. With the heads flipped over here to the combustion chamber side, you can see that these are what I believe is a 64cc combustion chamber. They have a 1.5-inch exhaust valve and a 1.72-inch intake valve. I don't think these heads have ever been done before. If I can get down here close enough to see those valve seats, they're actually pretty nice for as old as what these are. I don't think anybody's ever touched them before, but we do have some issues. I'm just gonna do a wiggle test here. This is a old Myra Pilot that should fit these, and you can see it's nice and tight in that guide there, but then we get over to some of these others. This exhaust over here completely wiped out, and also has taken out the valve seat. You can see that seat there is not beat out nearly as much as what that one is from the valve guide being wiped out. But we will be installing new valve seat inserts here to help take care of that problem and set these up so they'll burn unleaded gas and not have this problem again in the future. And that seat should go in there and completely restore that back to like new conditions, and actually better because it'll be a hard seat that'll stand up to the unleaded gas we have nowadays. I think probably the first thing I ought to do is take these over to the other bench and we'll magnaflux them, make sure there's no cracks. So to do my magnetic particle inspection, I use this electric yoke here that will magnetize the head, and then I sprinkle these painted iron filings onto the area that I'm magnetizing, and if there's any breaks in the casting here where I'm magnafluxing it, the magnetic force will pull that powder right directly into the edges of that defect, and I can see where there might be a crack. I don't see any on these. Flip them over on the other side here. Sometimes on the Chevrolet heads, if they've been frozen, you can occasionally find a crack kind of along this parting line in the casting on the outside, so I always like to check in that area. Not seeing anything on these, nothing unusual at all. So I think we can clean that up just a little bit and consider them to be good. I've got the head mounted up here on the TCM 25, which is where I like to do my guide and seat installation work. And whenever you're working on something like this, you need to continually watch for defects that you may or may not have noticed along the way prior. And looking at these bolt holes, I don't know if you can see that on camera very well. The threads are a little sketchy down in there. They're kind of, few of them kind of busted up. Few that are missing there at the beginning, or that hole there, you can especially see how rough the threads look down in there. So I think this would be a good time to take a step back here, and let's put some helicoils in there and see if we can repair those. First thing I'll have to do is level the head so it's square to the spindle of the machine. Then we will drill the threads out. Then we will tap new threads into the hole we drill. Then we will use this tool here to install the helicoil. So the first thing I'm going to do is level this head side to side. And now I'll turn my level and make some changes front to back. There we go, bubbles coming back in. Check my side to side again. That should be fine. I'm going to put just a little bit of coolant in those 3 holes that I'm wanting to repair the threads on. Float the table over. Drill out the old threads. Here I can feel I hit the bottom of the hole. Blow the cuttings out of that hole. Take out the drill bit, and while I'm still positioned in that exact spot, I'm going to go in with the tap. I'm going to stop there. You have to get a tap handle, and I will finish taking this all the way to the bottom with the tap handle. I've got it started nice and straight with the machine here, but I don't want to take a chance of hitting the bottom of the hole and maybe breaking the tap. Okay, those threads are done. Let's move over to the next. Okay, we're ready to drill the last hole. That one may be a little bit hidden from you on camera. And with the installation tool, I'll slip that in over that tang that's on the bottom of that coil, and I should be able to screw that right in. I'm going to put that in until that top is down in deep enough so that the top part of that coil is fully engaged in a thread, so that when the future user of this starts a bolt in, he'll be less likely to start pulling the coil up out of there right away. And it should screw right in. Okay, I like where those are at. Now I should be able to go down in there with a punch of some sort and hit the end of that tang, and they are scored so that they break off. And then generally you can take the air hose and blow in there and it'll pop that right up out of there. There it went. There that one went. think that one's out of there. I can't see it anyway. I didn't see it come out, but it's not there. But yeah, it screws in, good solid threads again. Our next step was to put the valve guides in. So let's level up as well as we can off of the old intake guides. So I'm going to start with one on this side here. And since we're working off of trying to level up off of worn valve guides, they're not perfect anymore, I'm going to kind of take an average. I'm going to go down to the opposite end of the head here, pick one that was in pretty good shape yet, and I'm going to split the difference between those two. There, we are pretty darn close. Put in our core drill. It is piloted to the old valve guide, and then it has a drill portion and a ream portion that should get those finished so we can install a replacement valve guide. We're going to run this in about the 250 RPM range. That looks about right. So we can just float over down into the guide. Make sure everything's tight. Give it a little bit of coolant. And there we go. Float over to the next one. Center up. Alrighty. That leaves me with just a shell of a guide there from the original. And I have a tool here that I made out of a drill bit that will go down inside and trim that off flush, make it look real nice before we put the new guide back in. You can see that's so thin it just kind of breaks away. And that's exactly what it would do if we attempted to put a new guide inside that little thin shell. You can see now that I've trimmed those off. No jagged edges left. Everything's nice and clean, ready for the new guides to go back in. I'm going to brush out the holes we drilled for the new guides, spray a little press fit lube into them. I have this stop on my driver so I can just run them all the way down till I hear it bottom out. So now let's roll it back. And once again, we need to level it up. Now you can see these are quite tall. I'm going to need to trim these down, allowing for a positive seal that we'll be using at this point. So I want to shorten it up probably about 100 thousandths from what they were originally. So if I measure the height of the valve guide on the head I have not done yet, we're coming up here, give or take 750 thousandths It's kind of hard to measure with one hand here and hold the camera at the same time, but roughly in the 750 thousandths range. So I want to come over to this head and do the same, because right now we're clear up here over an inch. Come in here, start making a cut on this. If I stop right there, zero my DRO, I've got about 925. So 925 minus 650 is what, 275? So now, if I go down 275 thousandths more by the DRO, and I'm also going to set the stop at that point when we get there, so that I can do all the others just the same. Okay, there's my 275, 635. I'm happy with that. That'll be more than enough clearance once we put the seals on. So now I'll just go through and make them all the same. Okay, let's clean up our chips again. Machined off to the proper height. Chamfered on the top edge. Ready to finish the inside. So at this point, I want to run a reamer through these guides. This is 342 thousandths. It will get them real close to the finished size, but then we'll actually do the finish work with a diamond reamer, or excuse me, a diamond hone with some oil, and it'll give us a proper finish for the valves. Make a real slow pass through that. We are now within about 1/1000th of finished size. So I'm going to put a little bit of honing oil inside each valve guide. A little bit on the hone itself. Tighten the hone up. I need to brush them out just a little bit. Let's see if my pilot that I like to use is anywhere close to fitting. Oh yeah, that's just exactly where it needs to be. Yeah, it just drags a little. It's not loose, it's not sloppy, doesn't stick. But I can feel just a little bit of drag on it. Yeah, that's averaging almost 1/1000ths tighter than they were when we started. Let's see what a valve feels like in there. Do the wiggle test here. I can feel just a little bit of play in that. You can see it's free, it spins nice. Not that it's going to spin like that when it's in the engine, but it's a good test for me to see how the valve and the guide are fitting together. But I can feel just a little bit of play in there. On the exhaust, I imagine I'll be able to feel just a little bit more because the exhaust stem is a little bit smaller. And it does. I'm going to call that good. For doing the valve seats, we need to level the head. Side to side looks good, but to dial it in with the machine, we'll have to do one more step. This is the cutter setup I'm going to use for putting those seats in. This is a combination of our SERDI pilot, our SERDI fixed diameter seat pocket cutters. And this is an adapter to a number 3 Morse taper that I made so that the SERDI tooling will fit into my old Peterson TCM 25. So we'll get that snapped in there. I'm going to touch off on the edge of one of these intake valve seats. There we have it. And I'm going to zero my DRO. And I'm going to go down to the other end of the head. And I'm going to do exactly the same thing. And hopefully the numbers on my DRO will be the same. Okay, I'm off about 10 thousandths here. So let me make a little adjustment here. I'm going to touch off again and zero. Going to go down to the other end of the head. And touch off, and we are within 1/2 thousandths of an inch. That is plenty close. Now, maybe I ought to swing this out here and show you folks up close. This is the valve seat that was beat out so bad. Move over here. See, there's more normal wear. There's normal wear. Normal wear here. See the difference as I go down the line here? And then look at this one here, how wide that is beat completely out. That's where the valve guide was out. So we're going to attempt to cut that out and put new insert in there, just like we're doing on all the other exhausts. And I think you will find that that will clean up and won't even be able to tell the difference from what any of the others are. So let me kind of center up on that one right there. Let's double check the camera. Make sure we're in focus for you. Does that look good? Looks good to me. I want a little bit of lubrication on my pilot. Don't want that tying up in a new valve guide because that's going to be spinning in there for quite a while. So if I come down on here, and I'm just going to kind of rock that back and forth until I touch off, until I feel it touch off on the head there. Right there's that point. Looks good. I'm going to take my valve seat, and I don't know if this will be in the focus that you can see or not, but there's a stop up here above. I'm going to set that valve seat in. Get this adjusted just right for a stop. And now when I cut that, I can just go down the line and cut all 4 of those, and they should come out exactly the same. I'm probably going to run that in the 300 RPM range. So let's see what happens. Here we go. A little bit of coolant on it. Over to the next one. Now, we'll try that one that was in such bad shape. But my bets are it'll come out looking just like the others when we're done. Okay, there we are. I'm going to carefully swing the head out of the way, or the machine head out of the way. There we go. That one looks nice. That cylinder looks nice. That one looks good. And what do you think about this one over here that was so bad? Look at that. That pocket cleaned up. There is just a little edge up here that didn't quite clean, but there is plenty there that did. I'm not worried about that at all. I think by the time we put the valve seat in there, it'll be impossible to tell it was any different than the others when we started. So let me get the driver out. I have my seats ready to go here. So I'll lay one of those on top of each pocket we've cut. I have my driver and I have my hammer. Here goes. And I always stop just before I get to the bottom. Blow it out in case there are any cuttings that have gotten under the seat. There, we have our seats installed. We're ready to move over to the SERDI now, and we will finish those, actually put the angles on those for the valve to seat against, and most of the machine work other than the surfacing on this head will be done. I'm going to go ahead and set this head up here on the SERDI, and we'll start doing the seats. This fixture works really nice on these heads. Put my pilot in, the level, get it front to back. We're a little off on the sides here. There's some adjustments here that allow you to move each side independent. And again, it doesn't have to be perfect because the head of the machine compensates for any misalignment. There, we got it all locked down. Take my pilot back out, and I'll need to set up the cutters here. So I've set up the cutter head here for the SERDI. I have the correct pilot in there. I have a 3-angle cutter bit installed that will cut a 40 thousandths wide seat, and I have placed it in the guide here and adjusted that cutter as near as I can tell so it will match the original, possibly do. But anyway, I'll get that installed and we'll start making some light cuts. Alrighty, I think we're ready to start. So I'll slip down into the valve guide, center of the machine, and now I'm going to come down and make a very light cut. I want to see if I'm matching up with the original seat. It appears I am. So let's get one of the valves. And we just happen to have some green color. Let's put that on the valve and the seat. And spin the valve into the valve seat. That should rub off the color so we can see where we're seating at. And as you can see here, I'm about as close to the center of the valve face as I can get. I'm real happy with that spot. But the seat on the head here, I do need to cut just a little bit more. There's some pits still showing. So let me touch those up. And we'll just take ever so slightly more off the face of that. Yes, I like the way that looks. Let's go ahead with the rest of them. All of those look as they should. Let's put all the intake valves in and see how they vacuum. Okay. Let's turn this up the other way here a little bit. I guess you still can't see from this angle, so you're going to have to take my word for it. But that one is pulling 7/10 of a bar. Same way there, as is that one, as is the last one. Let me just take the camera over there and show you that. You can see my gauge. Come on, focus. Focus. What's the problem here? There we go. I'm going to put that one on. Needle comes right up. Turn it off. And it still holds it vacuum even when it's shut off. So I've got a good seal there. I'm happy with that. Okay, now as I'm getting ready to set up my cutter to do the exhaust valve, and since I don't have a seat already there, or the angles on the seat to match like I did in the intake, I'm going to use this pointer here, and I'll adjust that so it's pointing to the outside edge of where I want my valve, or where I want my valve seat to contact the valve. Then I take my cutter here with the 3-angle bit, I put this on there, and I adjust it the same way so it's out, so that when I start cutting, I should make a valve seat that will match my valve, and the outside edge of where the 30-degree and the 45 come together, because we're doing a 45-degree seat, where those two angles come together will be the outside edge of where it contacts my valve. I can put that in the machine. I think we'll start with this one. It's in an area that's easy, not only maybe for you to see, but also for me to see also. Center up on it. It's cutting my throat angle. There, it just started the seat itself. Going to make a 2mm wide seat. And I just see the top. Clear a few of the chips out of the way. And I want to see where they're contacting each other. See if I'm anywhere close to where I thought it would be. As you can see here, I'm way far to the inside of that valve. I need to adjust that cutter out a little bit more. But I'd rather err on the conservative side than to be too far out right off the bat, because you can always cut away more metal, but it's hard to put it back. Let's adjust that cutter out a little bit more. Again, I just need to watch for that top angle to come in. Slow this down just a little bit. You know, I think I can still go just a little bit more. Let's check how our depth is. I'm going to put a straight edge across on the valve stem side, because I would like these to come out about the same height as what our intakes are. And I know you can't see this, but I can. I could probably go okay. That looks more like where I want it to be. That's a good position. It's just a little bit past center. Let's check the depth. I might be able to go just a couple. I'm going to sharpen this, get a little nicer finish on this valve seat, and put it just a few thousandths deeper than I was. Yes, the looks of that. Let's check our depth. It is very close. Increase in depth, maybe 2 or 3 thousandths is all I'm looking for. Oh yeah, that gave me what I was looking for. Just need to make the others match. So on our surfacing machine here, when we get ready to mount V8 type heads, they're sometimes a little bit cumbersome. The fixture that came with this machine is kind of big and awkward. I mean, it gets the job done, it works fine, but it's just not as easy to set up as I'd like it to be. This machine works much better on heads off an inline motor than it does on a V8 type motor. So I had this old fixture here that we used to use on another surfacer that we have long since worn out, but I saved this fixture and thought I would try it on this machine tonight. And I did it off camera because I was a little unsure of how I was going to make this work. But I'll tell you what, I'll never do this again. This fixture just gave me fits getting this head mounted. There's an eccentric down here over on this bolt here that you use to level it from side to side, and then you have to use a jack stand under the back side of the head here to level it front to back. And I just fought and fought with this thing, but I've got it on there, I've got it mounted. We're going to go ahead and do both heads with this fixture, but I learned my lesson. I won't try this again. Okay, I have the cutter down there. Basically, I can just drag a piece of paper between the cutter and the head. So I know we're close. I'm going to back this off. Make sure our down feed is not engaged. I'll turn some light on. Start this thing. Come over the face of the head. Come down till I hear it touch. Okay, there we've just touched. And I can see I have little marks here, So that tells me I'm leveled in this direction correctly because it is touching all the way across. I'm going to zero everything, and let's give this, I don't think this head is warped much. Let's give it 2 thousandths and see what it looks like after one pass. So here we go. And I am going to put this on as a time lapse. There's not much to see here. We'll just let it go across. Let's see what things look like. It made its way across there, but I don't like the finish it left. I don't think I'm on a good spot on the cutting tool. So I'm going to rotate that a little bit, and we'll try this again, just make a finished cut. I'm going to remove the cutter, kind of show you what that is. It's nothing more than this small little puck. It doesn't even appear to be sharp, but the edges of that will just cut and cut and cut and leave the nicest finish you can ever imagine on a cylinder head. But again, they do eventually wear or get chipped. I can feel a chip on the edge right there. So I need to rotate this around to one of the better looking spots and see if we can get a nicer finish. Feed it back down till I hear it just touch off. Okay, it just touched off. It did change my dimension here by 0.5 thousandths. So let's take one more. And I'm going to slow it way down. And let's see what kind of finish it leaves for us. Actually, what we have there right now is not that bad, but I know this machine will do better. I think it would probably be fine on this engine, would not give any issue, but I know it is not what it could be. So let's see what happens with this cut. 3.5 thousandths. Appears to me it has cleaned everything up that needs cleaned. I can see one little mark there that's not going to matter, and there's a little bit of discoloration here that is not an area of concern. But I think if we give it just a 0.5 thousandths more, so let's take it to 4 thousandths. Come back, there we are, we're on the 4. Once the machine makes this pass across it, we will be completely done with the machine work. So we're back here again after having run these heads back through the jet wash. Final cleaning, brushed the guides all out. You can see we have the new valve guides in. Intake seats have been refinished. Exhaust seats had new inserts put in, hard inserts, not only to repair the seat that was beat out real bad on that one that had the guide out so bad, but also so these will stand up to unleaded gas now. We've surfaced the head gasket surface, put some helicoils in here to repair some threads that were bad. We're going to reuse the old retainers and oil umbrella shield here, but these are brand new springs, brand new keepers, O-ring seals. We're going to upgrade these heads with a positive Viton seal. We have all new valves back here, which are also an upgrade from what the original factory valves were, because these all have a chrome-plated valve stem that they did not have when they were new. Now, earlier in this video, I mentioned that I thought these were 64cc combustion chamber heads. I did do a little bit of research on that, and it appears that this particular casting is probably closer to being a 60cc head combustion chamber. And that would make these a little more desirable for most of your smaller engines, give them a little more compression. So let me get the camera set up here, and we will go to work getting these assembled if you want to watch while I go through that process. But I'm just going to run a little band of lubrication around each valve stem as I put it in. I usually kind of put it right in the keeper groove. That way, as I insert the valve into the guide, I feel like it'll pull a little bit more of that down into the guide, because you want those lubed up. We don't know how long these heads are going to sit before they actually run. Plus, even if they were started tomorrow, they need to have lubrication on there. I imagine this is for a restoration. Could sit for an extended period of time before they actually make this engine run again. How did I do that? All my parts went rolling across the bench. Whoops, I have some valves in the wrong place here. What'd I do? Whoops, I put an exhaust in an intake hole and an intake and exhaust hole. How come nobody said anything? Give me just a second here and I'll pick things up again. So now I have all my parts picked up and accounted for again. So we'll start out with putting on the valve stem seals, and a little bit of brake parts cleaner on these always makes them slide on a lot nicer. Brake parts cleaner makes those seals slide on real easy, and after they're in place, it dries and they seem to stick. Never ever go anywhere. Much better than if you have oil under them, because the oil sometimes can let them slide back up off just about as easy as they went on. Using a positive seal, in my opinion, really helps with the life of the valve and guide, because even though that positive seal greatly restricts the oil at times, also keeps the oil metered to the valve stem and guide all along, and we actually have better guide life using the seals than before, like what this engine was originally, where there was nothing other than that O-ring to act as an umbrella to prevent the oil, to shed the oil off and keep it from going down the guide. Put a spring on, pull it down, being careful not to go down so far that I crush the seal. And then I'm going to go ahead and still put the original O-rings in there, along with a pair of keepers, and release that valve. Now, a mistake I see people make sometimes with a setup like this is they put the O-ring on the valve stem first and then run the retainer down, and they just push the O-ring on down the stem, and it does no good. But the idea of this setup is when you pull that retainer down past where that O-ring groove is, and you put your O-ring in that second groove that's on there, and then put the keepers in. When you release that, that pinches that O-ring in between the stem and the retainer and the keepers, and it seals that assembly, so any oil that comes down off the rocker arm and splashes on to the top of the valve stem is supposed to shed its way off the outside here, because it acts as an umbrella. But if you have that O-ring just pushed down the stem below the retainer, all it's going to do is just let the oil run right down the stem, right down the guide. You know, I used to think to myself, I wish I had a nickel for every one of these keepers I've put in over the years. But with the way things are at this point in time, maybe I'll be thinking more about having $1 for each one of them, because a nickel just doesn't go very far anymore. Now, had I had one more O-ring left when I got done, I'd know I missed one somewhere and would have to go back and figure out why and where. So that's why I always count them out so I know when I'm done. So let's turn around here, move this over to the SERDI, and we'll vacuum test these. We'll start on the exhaust side here, see if that'll pull adequate vacuum. Looks good on the gauge here. I can release or turn off the vacuum pump, and very, very slow leakage there. Feel comfortable with that. See, this port I have to also block the crossover to check it. Looks good. 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 Let's spin around, try the intake side here. Good. 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 And again, when I shut it off, it holds vacuum. Nothing at all wrong with that. So there you have it, folks. A pair of 1966 283 327 heads, casting 3884520. Completely rebuilt. Castings cleaned, magnafluxed. All new hardened guides installed, all new hard exhaust seats, all new valves with chrome plated stems, which is an upgrade from factory. New valve springs, all new positive Viton seals. I don't think you could make these heads any better than what these are for a stock application, just a restoration. I think these heads are better than they were when they were brand new. In fact, I know they're better than they were when they were brand new with the parts that we've installed in these heads. So give me your thoughts. I'm curious. Tell me what I did right. Tell me what I did wrong. Tell me what I should have done. Tell me what I shouldn't have done. I want to hear it because I try to do a better job every time I do a job. And I know these heads are far better than the work I did 40 years ago when I first started out. And I want to continue to improve and always do better. So critique these things. Tell me what's right. Tell me what's wrong. I want to hear about it. And as always, thank you for following. Like us, subscribe. It helps us out. Everybody, have a great day. Thanks.